Over the last decade, there's a phrase I've heard more times than I can count. Just run it on Kubernetes. Scaling problems? Kubernetes. Deployment problems? Kubernetes. Infrastructure problems? Kubernetes. And I understand why that happens. Kubernetes is one of the most powerful infrastructure systems ever built. But after more than 2 decades working with large production systems, I've also learned something architects eventually discover the hard way. Most technologies don't remove complexity, they relocate it. And Kubernetes is one of the clearest examples of that relocation. The first time I saw Kubernetes adopted inside a large organization, the expectation was very clear. The leadership team believed Kubernetes would simplify operations, developers would deploy containers, the platform would take care of scaling, and infrastructure complexity would largely disappear. But the opposite happened. Within a year, the company had created an entire platform engineering team just to operate the cluster. Networking policies, ingress management, cluster upgrades, security configuration, scheduling behavior. The system itself hadn't changed very much, but the operational layer around the system had become dramatically more sophisticated. And that experience forced me to rethink what Kubernetes actually is. When I explain Kubernetes to architects, I usually start somewhere else, with the problem it was originally built to solve. Long before Kubernetes existed, Google was operating infrastructure at a scale that very few companies had ever seen. Tens of thousands of machines, thousands of services, workloads constantly starting and stopping, machines failing all the time. At that scale, the problem wasn't writing software. The problem was coordinating workloads across an enormous fleet of machines. Something had to decide where a service should run, how resources should be allocated, when workloads should restart, and how the system should respond when infrastructure inevitably failed. Inside Google, that system was called Borg. Kubernetes is essentially the open-source evolution of that idea. At its core, Kubernetes is not an application platform. It is a cluster coordination system. It continuously observes the state of the system and tries to bring it back to the desired state. That's the real problem Kubernetes solves. And this is where many organizations misread the technology. Kubernetes assumes something very specific about the environment it runs in. It assumes you already have many independent workloads, frequent deployments, infrastructure spread across many machines, and failure happening regularly. In other words, Kubernetes assumes you are already operating a complex distributed system. When that assumption is true, Kubernetes can be incredibly effective. It becomes a coordination layer that keeps large fleets of services running. But if that assumption isn't true, if your system is still relatively small, then Kubernetes introduces a level of infrastructure sophistication that the system may not actually need. And I've seen that happen more times than I can count. One thing I often notice when teams discuss Kubernetes is that the conversation quickly becomes technical. What container runtime to use? Which ingress controller? Which observability stack? How to structure deployments? But architects should be asking a different question first. A much simpler question. Where should the complexity of this system live? Every distributed system has complexity somewhere. Sometimes it lives in the application, sometimes in infrastructure automation, sometimes in operational processes. Kubernetes moves that complexity into a programmable orchestration layer. And when your system is large enough, that can be an excellent trade-off. But if your system is still simple, you may simply be moving complexity into a place where it didn't previously exist. And this is where Kubernetes becomes interesting from a systems perspective, because once you introduce Kubernetes, you're not just deploying containers anymore, and that control plane comes with its own architecture, its own operational responsibilities, and its own complexity. Once Kubernetes becomes part of the system, something subtle but important changes in the architecture. You are no longer just operating an application. You are now operating an orchestration system that governs how that application runs. It has controllers constantly reconciling system state. a scheduler making placement decisions, networking layers managing service-to-service communication, storage abstractions mapping workloads to persistent infrastructure, security policies governing how workloads interact. When I walk through Kubernetes environments with engineering teams, this is usually the moment where the realization happens. The cluster itself is no longer just infrastructure. It's a distributed system that exists to manage other distributed systems. And once you see it that way, Kubernetes stops looking like a deployment tool and starts looking like what it really is: an operational control system. One of the things experience teaches you as an architect is that complexity rarely announces itself clearly. It appears gradually. A networking issue between pods, unexpected scheduling behavior, a resource limit that triggers cascading restarts, an upgrade that changes cluster behavior. None of these problems are unusual. They are simply part of operating a sophisticated orchestration platform. But what they illustrate is something important. When Kubernetes becomes part of your architecture, your system now has two operational layers: your application and the orchestration system that manages it. Both of those layers can fail. Both of those layers must be understood. And both of those layers must be designed carefully. Over time, something interesting tends to happen inside organizations running Kubernetes. Responsibility begins to shift. Developers want to focus on application behavior, business logic, feature delivery. But Kubernetes requires a deep understanding of infrastructure behavior: networking, scheduling, security configuration, observability. So gradually, a new engineering discipline emerges: platform engineering, a group responsible for building and maintaining the internal infrastructure platform that application teams rely on. When this model works well, it's incredibly effective. Application teams deploy services quickly. The platform team maintains the operational foundation. But from an architectural perspective, it's important to recognize what has happened. The organization has built a platform whose job is to operate the platform, and that only makes sense when the scale of the system actually demands it. This is the part of the conversation where I usually ask a very simple question: how big is the system actually going to become? If the answer is hundreds of services, many independent teams, continuous deployments, infrastructure fleets spread across regions, then Kubernetes starts to look like a very rational architectural decision, because coordinating that environment without a control plane becomes extremely difficult. But if the system consists of a small number of services, a predictable workload, and a handful of engineers maintaining it, then the architecture might benefit from something much simpler: managed containers, serverless infrastructure, or even traditional deployments. Because architecture is not about maximizing technical sophistication. It's about minimizing the complexity the system actually needs. One of the reasons I enjoy these discussions is that Kubernetes is a perfect example of something systems thinking makes very clear. Technology decisions are rarely about the technology itself. They're about how complexity flows through the system. Kubernetes moves that complexity into a programmable control plane. Sometimes that trade-off is exactly right. Sometimes it's premature, and part of the architect's job is recognizing the difference. Kubernetes is one of the most powerful infrastructure systems our industry has built. But it was never designed to simplify systems. It was designed to coordinate complex ones. And when architects understand that distinction, Kubernetes becomes much easier to evaluate. Because the question is no longer, should we use Kubernetes? The question becomes, is our system complex enough to justify the control plane Kubernetes introduces? And keeping that in mind, is systems thinking for architects